In this tutorial, we'll do a little getting started in RStudio. We'll do a few things. We'll basically just talk a little bit about the interface, how to do some calculations, and then how to manipulate some quantities in RStudio. So the first thing we'll look at is the RStudio interface. So when we open the RStudio interface, we get something that looks like this. There are typically three windows. This is called the console window, as you can see. This window is where we do all of our calculations. Over here, we have I don't know exactly what this window is called, but it does a couple of things. We can look at the history of any computations that we've done, as well as the environment, and we'll talk more about this later on, but right now we won't deal with this window. We may not deal with it at all. Excuse me, we will as soon as we start defining variables, but we'll use it just to be able to see exactly what objects we've created. So basically, when you're working in RStudio, when you define a variable or you define any sort of table, you're basically creating something called an object. And then you're performing some sorts of operations on that object. So objects are just any things that we define, and those are going to show up in this environment. So right now we haven't defined anything, so it says environment is empty. Down here in this window, depending on what your default screen is, you may start off in the files, and then also as we start to create plots, the plots will show up here, our most recently created plots. If we want to install additional packages, then we would do it here, and that's in a separate video. And then we can pull up things like help menus. For example, here I was dealing with a data set that deals with the Motor Trend US magazine, and or excuse me, in US magazine, and basically you can get help on functions and things like that. And then the viewer will see if we ever need that. So basically anything that we do in here. And so what this is called, this is a line-by-line computation interface. What we can do in here is basically anything that you can think of in terms of basic calculations. So if you want to do 5 plus 5, you type in 5 plus 5 and press enter, and you notice that the way the answer shows up is a little odd. First of all, these lines that have the little sort of the right arrow, that's where you're going to start typing in your line, and then anything that appears below it in black is the output. So the answer is 10, we know that, and this is just defining the fact that this is a list of just a single value. So we could do other computations as well. So maybe we want to do 5 plus 5 in parentheses, and we want to divide that by 1 plus 1. Well, that's really just 10 divided by 2, and so we should get 5. Again, we just get a single numerical answer. There are functions in here, so if you're doing things like square root, there are abbreviations, and that's in a separate document of shortcuts. But if you want to do square root, it's this, I call it the squirt function, SQRT, and then parentheses, you type in whatever you want to take the square root of. So let's say the square root of 9 should return the value of 3. So this can work just like a TID3 calculator in that it can do computations, but it has a lot more power. You'll notice at this point that nothing has been stored in our environment because we haven't really defined any objects. We've just done some basic scalar calculations, some basic numerical calculations, and those aren't being stored anywhere. So that isn't necessarily what we're wanting to do most of the time, because most of the time we want to define variables and have them take on certain values. So in our next discussion, our next part of our discussion, variables are very useful, and we can create a variable by doing it one of two ways. One way is, let's just say we want to take x and we want to assign it a value. So we want to say x equals, and you don't really need spaces in here, you can just say x equals 10. And so the second I press enter, if you keep your eyes over on the environment, where it says environment is empty over here, the second I press enter, suddenly it populates. So it says values, right? This is a value, a single numerical value, and it says x. If I put my cursor over x, you get that little drop down, and it says x is numeric, and it takes up 48 bytes on your computer. Nothing we need to worry about. It's important that it's stored as a numerical value. The other way you could do this is by actually taking x, and then we're going to create an arrow pointing to the left by doing the less than and then a dash. And so basically what we're saying is take the value of 10 and push it into the value of x. And let me just make this a different number so you can see up here in our environment, when I press enter, it will overwrite the value of 10 and make it 8. So now x is set equal to 8. So you can either use that sign or you can use the equal sign. The next thing we want to look at, and so here's the cool thing. So if I want to now take the value of x and I want to divide it by 2, well, that's going to take 8 and divide it by 2, which is 4. So if I press enter, it will produce that result. Now it knows that x takes on the value of 8, and dividing it by 2, it can do that computation. Now if I had a variable that I didn't define, like maybe y, and I try to divide it by 2, you're going to get an error. It's going to say object y is not found, because we haven't defined any value for y. The next thing we want to look at is, well, what kind of data types are there? We just looked at the instance of a value, which is a single numerical or categorical value. So x can take on a value like 2, or x can take on a value like cat. So let's just try to redefine x and have it take on a non-numerical value. So what if I just said x equals cat? All right. Well, first of all, when we look up here, it says now x has become a function. So what it really did is it didn't quite understand what we meant by x equals cat. See, cat is in blue, so it's thinking you're assigning x some quantity or some variable that's called cat. And so it's done some weird things here. So when you're defining a categorical value, you actually would need to say x equals quote cat. Because cat is technically a word, it's not a numerical value, and the quotation marks distinguish it that way. So now when I press enter, you'll notice that it's converted x back into a value, and it's assigned it the value of cat. If I press x, should just return that x is equal to cat. Going back over here into my environment, if I put my cursor over it, it defines x as a character. Now, a character is basically a letter, or can be a set of letters, and in this case, x is a set of letters. This is going to be useful when we're dealing with qualitative. Let's say you're looking at studying two groups of people who are fifth graders and people who are in college. Well, maybe you want to say, you want to assign a value to each person as, okay, they're either in fifth grade or they're in college, and then you want to give them maybe a value that you measured from them. Like maybe you're measuring heights of fifth graders and college students. So using categorical variables becomes pretty important. And same thing, we can do x, the less than sign, the dash, and we can type in the word cat in quotes again, and it didn't change anything because it was the same value. If you want to edit something, like let's say I made a mistake and I accidentally didn't close my quote. So I just did x is quote cat, no close. Well, now it's going, if I press enter, it gives me a plus sign because it's like, hey, wait a minute, you didn't complete it. So I would want to make sure to close that quote, press enter, and now it recognized that I was trying to assign a value to it. You can see that it kind of came out goofy, so it assigned it cat/n. I don't want that, so what I'm going to do is, if I press the up arrow, and I keep pressing the up or the down arrow, it'll let me toggle through my previous entries. So here I made the mistake, x assigned the value of cat, and I just want to go and close my quote, press enter again, that way I don't need to type it in all from scratch. So just as a brief recap, we can take a variable and assign it a numerical value like x equals 3, and if you do that, you're just going to redefine the value of x regardless of what it was before. If you want to do a set of text, and the cool thing is when you press shift and the comma button, you get the double quote, so you can just basically start typing in what you want, which saves you an extra keystroke. So we can call this dog if we want, and now it'll redefine it as dog. So we can have numerical or categorical variables. Remember, a category is just a non-numerical value. So it could be a letter, it could be a title, it could be a person's name. Those are all categorical. Quantitative or numerical values are ones that you can actually manipulate numerically. Now, if you try to take x divided by 2, you're going to get a problem, right? Because x right now is assigned to be the value dog. And it says error in x divided by 2, non-numeric argument to binary operator. So basically what this is telling us is that we're trying to take something that's non-numeric and divide it by something that is numeric. And of course we know we can't do that, because if you divide a dog into 2, you don't have a very happy dog. In the next thing that we'll look at is creating a vector. Now vectors are important because a lot of times we have a set, a data set. So let's say what we want to do is we want to create a set of values, x and y, so that x and y represent some sort of ordered pairs. Okay, so for instance, let's just say that we want to input the data x, y, and we essentially maybe want to just do some ordered pairs like 1, 2, 3, 4, and then maybe y is going to be 2, 4, 6, 8. So maybe we want to do some sort of regression later on. So the first thing we're going to do is we're going to create a vector of just creating the x pairs, or the x values. So what I'm going to do is there's this notation to create a vector or a list. Vector and list are pretty synonymous for us. And so what we're going to do is instead of saying x equals and then trying to assign it 4 different values, we're going to use this C operator. And what the C operator does is basically this says take x and concatenate it with, or store inside of x a set or series of values. So the way we're going to do that is we're going to say x equals C parenthesis 1, 2, 3, 4, close parentheses. So let's go back and do that. So we'll say x equals C 1, 2, 3, 4. If you're more comfortable putting spaces in between things, feel welcome to do that, but you don't necessarily need to do that because R can interpret things in between spaces. So now when I press enter, notice that it still assigns x to be a value, but it says it's numerical, and then it gives us this box notation and it says 1:4. Well, what that means is that we have 4 entries, 1, 2, 3, and 4, and here are those entries. Maybe just for demonstrative purposes, let's say that x is, I'll change this back, but let's say x is just a list of 4 values and they're all 2s. It still displays as x is numeric. It's a set of values of 4 different values, so there are basically 4 different indices. So this is value 1, this is value 2, this is value 3, this is value 4, except they're all stored as 2s. So let me change that back real quick. And now I can do the same thing for y. Well, my y values are 2, 4, 6, and 8, so I'll do that the same way. I'll say y equals C parentheses 2, 4, 6, 8. And when I press enter, now you notice that a second value appears, and now I have x pairs and y pairs. The x pairs are labeled 1, 2, 3, 4. The y pairs are labeled 2, 4, 6, 8. I can still perform things like operations on these. For example, if I want to just take every single value in the x vector and divide it by 2, I can say x divided by 2, and it's going to report back one line, and because it's just one vector, and the values are now 0.5, 1.0, 1.5, and 2.0, right? Because if we divide each of these by 2s, we get these respective numbers. Let's say that what I really want to do is create a table. So that defines our last type of situation where we have a data frame. Okay, so a data frame is basically a table or a set of multiple vectors joined together. So what I'm going to do in order to join together x and y, I'm going to give this a name. I'm going to call this, maybe I'll just call this D frame. You can call it anything you want. And we're going to say D frame equals. Okay, so what I want to do is I want to bind x and y together. So I'm going to do this function called C, but I'm not going to do parentheses. I'm going to do C bind. And what C bind will do is it will take x and y, so I'll just do x comma y, and it'll bind them together into a data frame. So I'm going to press enter, and now notice what shows up here. Now it says D frame, and it gives me kind of 2 dimensions here. It gives me a 1 through 4 and then a 1 through 2. Let's pull up D frame by just typing in D frame and pressing enter. Oops, I misspelled it, so it's telling me I misspelled it. And now you'll notice that it has all of these, that basically has 1, 2, 3, 4 rows, and then it has 1, 2 columns labeled x and y. So what I've effectively done is I've just created a table out of 2 vectors. We'll work a lot more on this later on, but this just gives us a basic idea as a recap on doing basic calculations, assigning values to variables, realizing that there are 3 different data types that we'll be using, a single value, a vector, which is just a list of values, and a data frame, which is a table of vectors. So basically, this is kind of the biggest, more complex one, and this is as simple as a single numerical value.